Bismillahirrahmanirrahim. Assalamu alaikum to all of you. This is Abdul Ghaffar Abbasi here to conduct chemistry class. Today we will discuss another topic related to the chapter number 2, that is states of matter. The topic which we will discuss, that will be general gas equation, or the equation of the state of gas, or ideal gas equation. These are the three names related to this topic. So introduction. By combining these three laws which we have already discussed, like Boyle's law, Charles' law and Avogadro's law, we get an equation, and that will be the ideal gas equation. So according to Boyle's law, volume of given mass of gas is inversely proportional to the pressure if the temperature remains constant. This is the equation for the Boyle's law, and this is the equation for the Charles' law, that volume of given mass of gas is directly proportional to the absolute temperature and the pressure is kept constant. Then the last one is Avogadro's law. According to Avogadro's law, volume of gas is directly proportional to the number of moles, that V is directly proportional to N. This is the equation number 3. Now we will combine these three equations, and then we will get the ideal gas equation. Now combining these three laws, we will get volume will be directly proportional to 1 upon P multiplied by T and N. These all values we have combined. Then if we remove this proportionality constant, as you know that we have to place a constant. So we have placed a constant here, that is R, and if you again rearrange this equation, then it will become as PV is equal to nRT, and R is the constant here. So this equation can be rearranged in this way, that PV is equal to nRT. This is known as the equation of the state, because when we specify the four variables, pressure, temperature and volume and number of moles, then we will be able to define the state of the gas. So that is the reason it is called the state of the equation of the state. Now where R is a constant, and that is called gas constant, above equation is known as the equation of the state or ideal gas equation. Here R is called as the universal gas constant, and value for R is equal to 0.0821 dm cube atmospheric per mole per Kelvin, and R has the different values in different system of units. So this is the universal gas constant, and it has this value, that is 0.0821 dm cube. Now another form of ideal gas equation there is. We can write the ideal gas equation into another form. Say suppose for 1 mole of gas, that will N will be equal to 1, therefore PV is equal to RT. N will be 1 means no need to write 1, that will become PV is equal to RT, or in other words we can rearrange this, PV divided by T is equal to R. If the pressure changes to P1 and temperature changes to T1, then the volume will also be changed to V1. So now we will put these values into equation. Now we can write as P1 V1 divided by T1 is equal to R. Similarly for the final conditions, P2 V2 divided by T2, and R will be the constant. Now we combine these both equations A and B, then we will get P1 into V1 divided by T1 is equal to P2 V2 divided by T2. This is the equation, another form of the ideal gas equation. Or we can write in this way, Pn means any state, any number, and Vn and Tn, then that will be equal to R. So this relationship is used to solve the problems regarding changes of volume of gases due to changes in the pressure and the temperature. So today we have discussed the ideal gas equation, or we can say that is equation for the state, and then we have discussed the two forms of the ideal gas equation. And as you know that ideal gas equation is the equation formed by the combination of these three laws: Boyle's law, Charles' law and Avogadro's law. So I hope you understood this topic. Thank you. Allah Hafiz.